Okay, question one. Ask you which gas has the fastest moving speed at 25 degrees Celsius? A. Oxygen. B. Chlorine. C. CH4. Methane. D. All have same average speed. So this question is asked you, are these gas at 25 degrees Celsius or at 25 degrees Celsius? Which gas move fastest? In the PowerPoint, we learned the lighter gas move faster, same temperature, right? Or at 25 degrees Celsius, same temperature. The lighter gas move faster, heavier gas moves slower. Do you remember this? Then which gas is lighter? Of course, this. This is a 16. 12 plus 4 hydrogen, each hydrogen 4, 16, right? So this is 16 gram per mole. You may think this is lighter because this oxygen is 16, but the oxygen gas is 2 oxygen atoms. 16 times 2 is 32. Okay. So clearly this is lightest. This is second. This is heaviest. This is 35.45 times 2 is 70.9. Okay. So this is lightest. So this moves fastest. CH4 is the lightest molecule, so move fastest. Again, this is all at the same temperature, 25 degrees Celsius. Okay. Then, are you okay? Question one. Okay. Then question two, still these three gas. Ask you which gas has the highest average kinetic energy. Okay. In a slide about molecular model of perfect gas, last point 4, tell you at the same temperature, two different gas will have same average kinetic energy. Right? So clearly this is D. At the same temperature or at 25 degrees Celsius, then all these gases will have same kinetic energy. That's why lighter gas move faster. Heavier gas moves slow. Kinetic energy is 1/2 mv squared, right? At the same temperature, this is the same. Then heavier mass, m is heavier, then v will be slow, smaller. Make the 1/2 mv squared the same. If this m is lower, lighter gas, then speed v will be greater, right? So this choice is D. All have same kinetic energy. Okay. The rest you need to work. Okay, I leave enough space there. 3. At 67 degrees Celsius, 750 millimeter mercury pressure, 2.1 liter gas. The mass is 4.35 gram. Ask you molar mass. So molar mass we have a formula is molar mass equals to dRT divided by P. Right? This is the formula to calculate the molar mass. So in order to calculate this molar mass, we need to know dRT and P. R is gas constant. I provide you this number here. T also tell you, but you need to convert to Kelvin. So anyway, it's a non-value, right? P millimeter mercury convert to Kelvin. Convert to ATM. Anyway, is known. Then only D then tell us mass and volume. So we can calculate the D. Density equal to mass over volume. Mass is 4.35, volume 2.1 liter. So calculate the density first. 2.07. No, this is non-value, right? We can plug in the number. So D R, use this number I gave to you. Don't change it. We have several students change the value. Don't change it. In any test, if a constant give to you, must use that number. If you change it, your answer will be wrong. Get no credit. 0.08206 liter ATM per mole per K. Since it's a per mole per K, so your temperature must be in Kelvin, cannot be Celsius. So temperature not 67 plus 273.15 K. Okay. If you use plus 273, that's fine. But you cannot use Celsius directly. Then pressure. Pressure, this R is ATM, so your pressure also must be ATM. 750 millimeter mercury. Converted to ATM, 760. Okay. Then ATM cancel this ATM. K cancel this per K. Liter cancel this per liter. Left over gram more. That is the molar mass. Use a calculator. You can easily get 58.6 gram per mole. Okay, this is regular way. We have this formula to calculate molar mass. We have a couple of students use another way. Since this is a gas problem solving, right? You think about the ideal gas equation. Ideal gas equation, P is non-value, T is non-value, R is non-value here, and V also tells you. Then we can calculate the N, right? Since P, V, R, T all known, so we can calculate the N. N is more. Right. Similarly, your P must be converted to ATM because R is based on ATM. V 2.1. T similarly converted to Kelvin. So we get Morse. I don't have a calculator with me. I didn't write down. So anyone have a calculator? What is more? moles.
It's
So
740.
750 divided by 760.
It's 7430.
Huh?
After the 0, 7430.
743?
Mhm.
Okay. 0.0743 more. Okay. So now we have more, and together with mass, right? 4.35. You see, I wrote here many times. From mass to more is mass divided by molar mass, right? The mass divided by molar mass is more. Then switch N with MW. N should be, MW should be M divided by N, right? Mass divided by moles is molar mass. So now your molar mass is mass divided by mole. Mass is 4.35 gram. Mole is 0.0743. Your answer will be same, 58.6. This is another way. I didn't talk about this method in the class, but we have several students working this way. Are you okay for question 3? Question 3 is the most complicated. I'll problem solve. Then 4. Question 4 asks you density of chlorine gas at standard temperature and pressure. Asks you density. So this formula, density, and this formula of molar mass actually come from the same, right? We just rearrange this equation. So density should be P times MW divided by RT, right? P times MW divided by RT. R is a gas constant, is a known value. Come from here, right? T, STP, tell you, STP, that means temperature is 0 degrees Celsius, 273.15 K. P is 1 atm. All right, so STP, TP, both are known value. Molar mass. So this is the only thing you need to figure out. What is the molar mass? With the help of periodic table, find the chlorine. Atomic mass is 35.45. Then chlorine molecular is times 2. So is a non-value. So with the help of periodic table, everything here is non-value. P is 1 atm. Molar mass 35.45 times 2 gram per mole. R gas constant. Use the number I have provided here. T 273.15 K. If you use 273, that's fine. Okay. Then this density will be 3.16 gram per liter. This is one way directly from this formula. We have another way. If you remember, one more any ideal gas at STP. What is the volume? If you remember this, one more any ideal gas volume we label as lowercase m is molar volume, means volume of one more gas, 22.414 liter. Then you can use this directly. So D will be M over V. Since this M is molar volume, then this mass will be molar mass, right? What is molar mass? The same. This is molar mass. So 35.45 times 2 unit is gram per mole. And this unit is liter per mole. So you get the same answer. So this is another way. If you remember one more any ideal gas at the STP volume 22.414 liter, then you can use this method. Okay. Okay, well, question 4. Then question 5. A tank contains 3 more argon, 5 more nitrogen. Ask you calculate the mole fraction of argon. Mole fraction, we use this, looks like an X. The actual is the correct letter, we call chi. And you can call this X, it's fine. Just mole fraction of this gas equals to more of this gas divided by moles from all gas. 2 different gas, right? So more of argon plus more of nitrogen. Argon 3, nitrogen 5, or 0.375. And the unit? No unit. This is mole divided by mole. No unit. Just pure number. Then B, if total pressure is 850 milliliter mercury, what is the partial pressure of argon? So partial pressure equals to mole fraction times total pressure. Okay, mole fraction we just calculate. Total pressure tell you 850. So you'll be 318.75 or 319. Unit millimeter mercury. You can keep it because I didn't ask you convert it to ATM. Okay, then question 6. Ask you how many moles of gas would occupy 28 liter at 27 degrees Celsius and 1.2 ATM. Ask you moles. This is very clear. You need to use ideal gas equation, right? Because tell you pressure, volume, temperature. Of course, you need to use this equation to calculate the N. What is the N will be? This is the same as I require you to solve this equation first day of class, right? Both sides divided by 5. Then this both sides divided by RT. Both sides divided by RT. This we have couple students. That means you don't know how to solve this type of equation. The first day I asked this, some of you may laugh. Everybody knows that happened again this year. So P is 1.2, V 28, or use this number directly when I provide to you. 0.808206 liter ATM per mole per K. T Don't use 10 to 7 directly. You need a converter to Kelvin. Okay. Then this more will be 1.36. Okay. Are you okay with this? The 7, this is the easiest calculation. Here, pressure is 935 millimeter mercury, RCU converted to ATM, atmospheric pressure. So 935 millimeter mercury converted to ATM, 1 ATM, 760. You're required to remember this number. This is a very common conversion factor. So you'll be 1.23 ATM. Okay, do you have any other question for this quiz 5?